Hi, this is Dr. Graves from the CSUN Geography Department and geographyplanet.org. This is part 2 of the tutorial instructing you how to conduct t-tests on sample. First round of tests we did, we compared independently drawn samples and compared them against each other. And then for the first part of this one, what we're going to do is take a look at comparing subsamples against the population sample in order to try to determine whether they are statistically similar or not. And then the very last part, we'll go back to our data, draw a sample from several different years, and then see if the average has changed over the years. So what you see on the screen in front of you is the average age of persons arrested for, I believe it was assault, by ethnicity in these columns highlighted in green above, and all persons arrested for assault over a 5-year period in Los Angeles. So what we're going to do is, one more time, we're going to run this t-test, and we're going to go ahead and use the same tool that we did this the t-test two sample assuming unequal variance. I'm going to just click OK, and the software remembers what I had compared before. So we have black there, and that's fine. I'm going to leave that, and for the second one I'm going to replace other and highlight this column here over here, all, and we can leave the hypothesized mean difference at 0 and the alpha at 0.05, and I'm going to make sure that the output falls over here somewhere. I'm just going to do this one time, and there we find that the t-stat is 1.87, which is just a little bit larger than the critical for the one tail and smaller than the critical for the two tail. So what that tells us is that we can be reasonably certain that 35.26 is statistically greater than 35.2159, but it's not statistically different. The two groups are not statistically different. That's the tailed test. If we were to say that, we would have a 7% chance of being wrong, and generally we won't accept anything over 5% for that. Okay, so that's the one way to do it. I'm just going to quickly show you another way of doing it. And instead, I can go up here to formulas and pull out statistical, and from here select t-test. And I'm going to do this similarly again. I'm going to highlight the first array here, which is the all group, everybody, and I'm going to press F4, which is going to add the dollar signs in this first array to freeze it. And then what I'm going to do, press Tab, and I'm going to highlight the data for black folks. We're going to just let's just go with one tail, and the type, when I click in here, is going to be 3, a 2-sample test assuming unequal variances. So then I just have to type in number 3. Click OK. Notice that the 0.035 matches the 0.035 here. Now the reason we would do this is that we can rapidly copy this across. We're going to get a lot of junk data, but if I press F2 here, I can see now that this is for Hispanic, because the formula indicates this array of data is now being used to calculate it. So I could put Hispanic here, delete these, press F2 or double click will also open the formula editor, and we can see that this is other, and then delete, delete, and then this must then be for white. Now I'm just going to delete some cells, and then I'm going to make sure that all of this data is in number format, increase the number of decimal places, and from this we can say that black people who were arrested, our sample of black people who were arrested for assault, are statistically most similar to the overall profile of people who were arrested for assault in Los Angeles. That the Hispanics, the other group, and the white group are all significantly different, either younger or older than the overall population. And so that's just a fast way to run that test multiple times over. And if you have the data set up so the columns are all adjacent to each other, it would be really quick that way to test various samples against the population mean. So this very last test that we're going to do, I'm going to go back to the main data. I'm going to click Insert Pivot Table once again, just to give you some extra practice on looking at that. And with this data, what we're going to do is grab area name as we have before. We're going to put this in the row columns, and we're going to grab arrest date and put this below it. And this is going to do some calculating here, and it's going to give us the years. And really what we want to do is now take years and put it over into columns. And we can grab and pull these other things up and away back into the fields major box. And then let's just grab charge group code, drag it down here, and change it from sum to count. That will tell us the number of arrests for pretty much all crimes during this time period. And then the last bit would be to grab the charge group description. We want to put that in there. And then we can filter out, well, what we would like. And so select multiple items and then select driving under the influence. And then that gives us multiple years of data for driving under the influence. And what I want you to do is just to copy these first handful of columns out, highlight it, Control C, and then we're going to scroll down here and paste it. And it's a lot easier to do these sort of calculations on data that isn't in the pivot table. But what we might do here is, while we're in the pivot table, if you click way up here at the top, Pivot Table Tools and Pivot Charts, it does some kind of cool things with this, and you can add some charts on here. And I want to maybe a line graph just quickly to help demonstrate what we're going to do. So each of the years has a line, and so 2015 is this dark blue and 2019 is the light blue. And with the t-test, we're asking, is this pattern different from year to year? And some of these patterns of data, maybe 2017 and 2018, mirror each other pretty closely, and so we might not be able to find a significant difference between those. But say that you're working for a group that has been doing have some kind of effort to reduce drunk driving, and you want to know, did your program work? And if it did, then there should be a significant reduction between say the year before you instituted the program and 4 years after you instituted the program. So in order to demonstrate or measure the decrease in the arrest data, we need to go once again to our t-test. So I clicked on the data tab. I'm going to click on data analysis, and this kind of test is called a paired test because we're using data from the same location, or it could be from the same person or same school, over years. And so we're assuming that it's essentially the same group of people that we are pulling this sample from on 2 different occasions. Click OK. Our range 1 is 2015. I don't want to include the grand total. And then range 2, let's go with 2019. And again, not including the grand total. We will leave the hypothesized mean difference at 0, and the labels are checked on, and the significance level there at 0.05. And the output range will not be cell R28, but just right here somewhere, H30. Okay. And what does that outcome tell us? Well, the t-stat is 5.96, and as you have probably come to learn, that is a pretty large t-statistic. It is far in excess of 1.72 and even far in excess of 2.08. And so then the probability, it's expressed as scientific notation, the chance that we would be making a mistake if we said that there was no reduction in the DUI. We can do that and suggest that this reduction from 582 on average to 389 is quite significant. I'm going to run this test one more time, but just down here, in which we use the other strategy by clicking on formulas, more functions, statistical, and then scrolling down until we find t-test. Array 1 will be the data in 2015. I'm going to press F4 to freeze that. And then array 2 will be the data underneath the year 2016. We're looking for an improvement, so this will be a one-tailed test, not a two-tailed test. And the type this time is the paired t-test, so that's 1. And 0.003 is what we get. I should move this one over. So the difference between 2015 and 2016 isn't isn't super large, and the difference continues to grow. I repeated the test. I'm going to press F2 so you can see what I've done to compare the data from 2017 and 2018, and what we see is 0.43, which would tell us that we would have 43% chance of making an error if we said that 2017 and 2018 were different. They're statistically the same. Yes, they have different number here, 8979 and 8903. Those are 2 different sums, but they are statistically indistinguishable. And 2017 to 2019 also indistinguishable statistically. So what we can tell from this data is that the huge change came between 2016 and 2017. Something happened between those 2 years that really seemed to have made a difference in the number of DUI offenses. So that concludes the tutorial on t-testing.